Hi there, this is exercise 9b, looking now at integration of those functions that we were trying to differentiate on exercise 9a. So this should be theoretically the reverse of that, and there are a number of different types of functions we need to be able to look at. So find the exact value then as a starter of this. Now we saw something similar to this actually with a differentiation. You can't differentiate or integrate this at the moment without first splitting it, and because it's all divided by this single thing 2x squared, we can write x cubed over 2x squared plus 3 over 2x squared. And the nice thing about this is that cancels with two of those, giving me half of x. The 2's on the bottom, you see, so that's still there, but I've got an x left on the top. And this one is 3 over 2. Now the x squared on the bottom, so I'm going to write that as x to the minus 2. Notice this is still meant to be integrated. Still meant to be integrated between the points 1 and 2. So I haven't actually done any integration at all yet. I've just rearranged it. So half x, when you do these, you add a power. And then you divide by this power. Now it's already got a 2 on the bottom. If I divide by another 2, that becomes 4. Plus 3 over 2. X, add a power to minus 2, be careful, it's not minus 3, it's minus 1. Divide by the minus 1, makes that a minus. This then has limits of 1 and 2, so I put 2 in. That's a quarter of 2 squared, which is 4, minus 3 over 2. Now this might be better, thinking of this as 3 over 2x. The x now is on the bottom, so the 2's on the bottom. So that makes that 3/4 there. That's the first one. And then I put 1 into this same thing. A quarter of 1 squared is simply a quarter. I mean, of course you can do all this on your calculator, there's no problem at all. When this is 1, it's 3 over 2 1s, which is 3 over 2, minus 3 over 2. So sort both of those out. That's 1 minus a quarter, that's a quarter. 1 minus 3/4 is a quarter, sorry. And this is a quarter, which is the same as sorry, 3 over 2 is the same as 6 over 4. So really this is a quarter minus 6/4, which is minus 5/4, but it says minus, so it's plus 5/4. So that's like 6/4, and I'm hoping the answer therefore is 3 over 2. Let's have a look what the answer is. Oh, there wasn't an answer, there you go. So I think it's 3 over 2, so you can let me know. In fact, I'll just check it on my calculator quickly. Well, the good news is that the answer was 3 over 2. I've just typed it into my calculator and that's worked fine. So integrating e to the x, the rule is simple. We already knew that if I differentiate, this is the way you write in differentiate e to the x, you get e to the x. So it's no real surprise that you integrate, you get back again. Notice we write plus c, because when you integrate, you always get plus c. And very often if you do a definite integrals, and of course then you wouldn't have a plus c, you very often leave your answer in terms of e, so it might be e to the 2 or e cubed or something like this. Or just simply if it was e to the 1. E to the 1 is very often just written e. If we integrate 1 over x type functions, now again we've already seen that if we differentiate log of x, you get 1 over x. So again, it's not really a surprise, I suppose. I mean, this is the area I'm interested in. This is the y equals 1 over x function. And so, as I've just said, if I differentiate log x, I get 1 over x. If I start with y equals 1 over x, it's not really a surprise to learn that if I integrate 1 over x dx, I get log x. Now, the surprise comes, I suppose, from the fact that normally the rule is add a power and divide by the new power. So, you know, this fits that bill. 1 over x is x to the minus 1. So if I integrate x to the minus 1, theoretically what I should do is add a power. If I add a power, I get 0. So x to the 0. And if I divide by that 0, I get a problem. This is not something you're allowed to do in mathematics, division by 0. So the point about this slide is, I suppose, that the rule doesn't work that you would expect to work, and yet we know there is an answer, and this answer turns out to be log of x. I don't really explain, it should be log x plus c, I suppose. Don't really explain why it's true. It just is for now, I suppose. And interestingly, if it was a negative number in there, you still find the modulus of that number. So that's our rule. Write it down, please, like all the others hopefully have gone down. So now let's have a look at this rule in action. On the face of it, looks like the starter we had. I suppose there must be a difference, otherwise I wouldn't have bothered with this question. So I'll just see if I can work out what the difference is. So I'm going to do it the same way as I did the starter. So you have to split this. There's no other way for you to do that. So I'm going to do the integral of 5x over the 2x squared minus 3x cubed over the 2x squared dx. And now I'm going to tidy both of them up. And I suppose this is the difference. Actually, you'll notice these x here on this example, there's more x's on the bottom. So that gives me the integral of 5 over 2x, and the x is on the bottom because there's more. Whereas this one, it's 3 over 2, and the x is, there's more of them on the top, so the x is on the top. But this is, I suppose, the key of why I'm doing it, because of this rule. If I integrate 1 over x, I've said you get log of x. So this gives me 5 over 2 log mod x. Minus, now integration, really not differentiating, integrating, so you add a power and then divide by the power. And if I divide by something with already a 2 on the bottom and divide by another 2, it gives 3 over 4. Don't forget your constant. Log x, that should really have had those, but other than that, that's fine. Integration of trig functions. We saw last time that when you differentiate cos and sine, you get sine x and then you get minus. Now I actually did this in terms of cos. Sine cos minus sine minus cos, you should remember that. So when we come to questions like that, we just got to bear that in mind. Interestingly, the next question hasn't got that on at all. This just looks like a straightforward logarithmic one. So if I was doing this, I'd be saying to myself, it's over x, so it's going to be 3 log x. That's between 1 and 2. So this is 3 log 2 minus 3 log 1. Now log 1 is nice because log 1 is 0, so I can ignore that totally. 3 times by 0 is 0. The answer is 3 log 2. And it does say you give your answer in the form a log b, so I've done that. 3 log 2. Find the exact value of this one. Well, again, we did say that if you integrate e to the x, you get e to the x. So my answer is e to the x once I've integrated. And then I have to put 2 and 0 into this. So if I put 2 in, I get e squared. If I put 0 in, I get e to the 0. Now normally when you put 0 in, you get 0 out. But here you don't. Because anything to the power of 0 is 1. So that's my answer. We talked about trig just now, so it says find the exact area enclosed by the x-axis and the sine x, y equals sine x. I'm just going to draw a graph. Don't imagine I've got a graph. So my sine curve looks like this. And you should know that this is 180 degrees, so that's pi. Now I have said in the past, you've got to differentiate and integrate in radians. And that's why over here we've got 0 and pi by 3. So between pi by 3, now pi by 3 then must be about here somewhere. It's actually 60 degrees. So I'm actually asked to find this area. That's what I'm doing. So to find the area, I integrate my sine x between 0 and pi by 3. dx. And I've told you already, if you ever get these sine cos minus sine minus cos. Now the one thing I want to tell you is that when we differentiate, I've shown you exercise 9a, you go down. By definition you go upwards to integrate. And this is what I want to impress upon you. So again, with differentiation I want you to write these down, and with integrations I want you to write these down as well. So when I integrate sine, and notice by the way, when you get to the top and you're going upwards, sine actually has to now go all the way back down to the bottom again, and it starts again. So this is actually equal to minus cos of x. Minus cos of x. Need a minus between 0 and pi by 3. So what do? We put pi by 3 in. That's minus cos of pi by 3. Now cos of pi by 3, it's cos of 60, is a half. So that's minus a half, because it's minus. And I've put 0 in. Cos of 0 is 1. So this is minus a 1. Minus a minus 1, sorry. That was me getting... I got it right, then I changed it, and then I put it back again. So that was really like plus 1. So this is like minus half plus 1. I reckon the answer is a half. Got there eventually. Half, yeah. Integrate cos of x. So again, sine cos minus cos. Now we're integrating, so we go upwards. And you'll notice cos goes to sine. So this is straightforwardly, it tells me what to do. It's the integral of that, and it's sine x. Between 0 and pi. And the integral of sine x then, and sorry, when you get sine x, you put sine of pi in, and you do sine of 0. Sine of pi is 180. Sine of 180 is 0. I get the answer 0 here. Minus 0 is 0. This is a bit rubbish. Yeah, there you go. And I suppose that happens because of this. This is we talked about this at year 12. This is a positive area. This is a negative area. If you look at those two pictures, those parts completely equal each other out. So the area is not equal to 0. But the integral is. So if that makes sense, if the area, you'd have to say, you can ignore the fact this is negative. You'd work out from there to there. And you get an answer. You work out from there to there, you get an answer, you add the two together. But here, I was asked for the integration, and the integration is 0. This part gives a positive integral, negative integral. How would you find the area? Well, as I kind of said, you would integrate it from 0 to half pi, and then double the answer. And if you do that, should we do it quickly? I've got a couple of seconds. Just cos I already know goes to sine x. And it's telling me to do 2 times from sine x from 0 to half pi. Now, if I put half pi in, that's like 90 degrees. Sine of 90 you should know is 1. So it's 2 times 1 minus sine of 0 is still 0. So I reckon the answer is 2. Oh, so delay, good. So look, that's a brief summation of all things for exercise 9b. We'll do a bit more prep for that during the lesson, and hopefully then everyone will be able to do them and it makes sense. Best luck.